of ANSYS Workbench tutorials. In this session, we are analyzing for topology optimization of an overhang beam. This is also known by the name of sunshade or Chajja in civil engineering terms. If you look at this, it is actually going to be an overhang beam from the main building, and it is mainly over the windows. It actually protects the room from excess sunlight entering into it, hence it is called as a sunshade. So we will try to optimize this structure that you can see here. There is another type of sunshade that I found for you. It looks like this. Now you must have generally seen that the sunshade has the fixed part or the end which is connected to the building to be a little more broader as compared to the other end. The reason is it is actually subjected to its own weight. So the maximum amount of stress would be generated at the end which is connected to the building. So that's where you need to add more material. And on the other side, you can actually reduce the material. And suppose if the amount of load is zero at that end, then we can say that there is very minimum requirement of material on this side. By numerical calculation also we have found in strength of material subject, you can go through the videos and you would understand that the maximum bending stress is generated at this end which is connected to the building. So let's optimize and analyze this overhang beam or sunshade or chajja as it is called for its topology optimization. This is done in 3 steps. We will first start by double clicking on static structural. I am leaving the material to structural steel. If you want, you can change the material to any other form, for example, concrete or something else. So I'll go to geometry, right click, new design modeler geometry. Units, millimeter, XY, look at. I'll go to sketching and I'll choose a very simple geometry for it, that is a rectangle. I'll give it some dimensions. Say it is 150 by 40 and I'll extrude it for 350 mm. Generate. So this is how the overhang beam would look like. This end would be connected to the building and the other end is the one which we are going to leave it as overhang. This completes the geometry. Next I'll go to model and double click on it. I'll go to mesh. I'll choose the relevant center to find and update. You can apply any other type of meshing that we have already learned through the other videos. I'll go to analysis setting. I'll choose the side and I'll insert fixed support. Now you can apply load or force on this edge, or you can apply some pressure on this surface. So let us apply pressure on this face of 50 megapascal. I'll go to solution and insert deformation directional. I want to see the deformation along the y-axis. I also want to see the stress equivalent and I want to see the strain equivalent. I'll go to solution and solve. So now you can see this is the directional deformation over this overhang beam. This is the equivalent stress generated whose value is 2579.4 megapascal. The maximum stress generated is always on this side, which is fixed. And equivalent strain is what we can see here. The maximum strain is here and the value is 0.012897. So this is how your overhang beam is going to behave under the fixed and the pressure effect. This is done. Now I'll go to topology optimization and I'll drag it over the solution. Then we'll go to setup and double click on it. Now you can see here we are in topology optimization. In analysis settings, there is maximum number of iterations that you can give. This is used for, it's a trial and error method for reducing the amount of material such that you are left with the minimum material and you can reduce the cost of it. So the number of iterations that have to be performed can be any number. By default, the value is 500. If you want, you can change this number to 1000 or any other value. Now here convergence accuracy is 0.1%. You can either increase this value such that the convergence accuracy is going to be 0.2% or 0.3%, or you can reduce it more. I'm leaving to what it is. The solver type here is program controlled. I'm leaving it to as it is. And store results at all iterations we are storing the value. And here there are certain more options that you can go through. I'm leaving them as it is. Next comes your optimization region. It is asking for the region which you want to optimize. Now you can see here by default it is geometry all bodies. So I'm leaving it to as it is. If you want, you can change this. For example, you can change any surface that you want to optimize. So I'm leaving it as it is. Now there is something called as objective. You can see your response type. You can change it from the default setting, that is compliance. You can change it to mass or volume. Same way, what is your goal? You can set. So I am leaving it to minimize. Obviously, for compliance, it is going to be minimized. So accordingly, you can change these things. Then you can go for response constraint. This is very important. Here, response, again you can choose. Either you can go for mass or volume or displacement or the reaction force. You want to, work upon these values. Say I want to work upon the mass of the overhang beam and percentage to retain. It is asking, so how much percentage of material you want to retain. So let me say that I want to retain 30% of the material and the rest I can avoid. So we will be left with very less material such that our cost of this overhang beam is going to reduce. Next I'll go to solution and here I'm not going to change anything, so we can directly go for solving it. Before that, just check that export topology STL file is generated. So you should always click it to yes and don't make it no, because you also want to see what happens when the mass is reduced and the same mass is subjected to the same boundary conditions that we have given initially. So that I'll explain in some time. As of now, just select the STL file to yes, go to solution and solve. The solution is obtained. We'll go for topology density, and here you can see this is the optimized version of the overhang beam that we had created. You can see here how much less material is required at this end, because this is the zone where there is least amount of stress, and at this zone where the stress is maximum, you can see the material has been completely retained. So we can see how much material is required for manufacturing of this overhang beam. You can just animate and see how was the original structure and how much structure is left now after the optimization of this structure. So this is going to end here. Now what we'll do is we want to transfer this results to another static structural module. So I will right click on it and transfer to design validation system is what I'll click on. So you can see another static structural module has opened on its own. Now I will go to results, right click, update. Then I'll go to geometry, right click, update. These two steps have to be followed. Only then you will be able to transfer the STL file which has been created in the topology optimization results into the static structural, which is the next module that we have created. And we want to see that if we apply the same amount of boundary conditions that we have initially applied to this module A over here, how will this new module react? So this is done. So we'll go to geometry and double click on it. If you double click, you can see to the left that space claim is opening of ANSYS. So let's go and see. So this is how it looks like. I'll uncheck the system 1 and I have just left the system 1 which is below checked. We'll go to edit sketch and then I'll select the space. I'll draw a rectangle to define all the points and then I'll click on copy and paste. So all the points have been created. Now I'll uncheck the system 1 and I'll go to repair. I'll fit the curves. I'll click on correct tangency and let me give this distance as 0.1 mm such that the curves are created very closely, and then when I click on the tick button all the curves have been created. Now if you want you can just change this curve such that the manufacturing is more easier. So what I'll do is I'll go back to design. I'll choose trim option and I'll delete these lines and I'll just draw a straight line from here to here. Now this lines that you see over here would be difficult to manufacture. So what I can do is I can just create a simple curve from here to this point and something like this. You can give an arch and then I would trim away these lines again. So rather than maintaining it, we can just go for deleting it. Be careful to delete all the small lines that you see. So I've deleted all of them. Now I would again use a line to join this point to this end. So that's it. I have created a very simple design. We'll select the pull option and click on it. I'll go to ruler and it is asking for the dimension. I'll give it 3 and this is done. I'll close it now. I'll go to model and double click on it. I'll just suppress the upper body and what remains is the lower one. Next I'll go to mesh like the first one and I'll select relevant center to fine, update. The meshing is done. Now I'll go to static structural. On this face I'll insert fixed support and on the top portion I'll insert pressure of the same value that I had applied before. I'll go to solution and I'll insert deformation directional. I want to see the deformation along the y-axis. Also I want to see the strain and most importantly the stress. I'll go to solution and solve. So you can look here. Now the dimension that we have given is too thin, hence it is showing that it's a little more deformation over the body. But you can give it a little more thickness, so it would be better. And you can see here the maximum stress is generated at this zone. The zone is still free from the stress. Hence, my design would be an optimum design because I am using lesser material as compared to the initial way that we had started by giving it a thickness of 20 mm. You can reduce it to 5 mm and that should be fine. I have reduced it to 3. You can make it to 5 and solve it. So this is how you analyze a object for its topology optimization, and you make it optimum such that the material that you are using is lesser, and when you use lesser material you get better cost for the same product. You can use quality material but less in amount, and also you would have a safer design. Always more material does not mean that the design is safe. Even lesser material but good quality can help. So this is a different pattern of sunshade which you can have with a different design rather than the regular one which we just saw. You can check here. This is one design which I initially had with me, and this is the other one. So you can have different patterns. You can have the sloping kind of pattern. You can have a arc kind of a pattern like we have created. This is also very much prevalent these days. So with this, I end the session. I hope you have understood the process for analyzing for topology optimization. We will take up another object in the next class. If you have any doubts, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.